Hello everybody, my name is Josh and I was a computer science examiner for multiple exam boards, head of computer science in UK based schools, and now I run a tutoring business. And these lessons are all to do with trying to help you as much as possible for your upcoming A-level exams. Now, the topic that we're going to be looking at today are the Pathfinder algorithms, which is Dijkstra's and A-star. This is relevant for all specifications, but AQA, you do not have to know the A-star algorithm. Cambridge International, OCR, you do. So we'll have a little look at how to do these, and we're going to start off with Dijkstra's. I'm trying to give you as little as possible to remember because I know time is so short. And one of the things that they could, which is probably going to be the hardest question, is they're going to ask you to simply trace through a Dijkstra's algorithm on a graph, and then you to be able to go through and actually talk through what's happening at each step. So let's say this is going to be the first part where what we're trying to do is we're trying to go through A to E, and what we have to do with Dijkstra's is we have to visit every single node. You sometimes do that in A-star, but generally A-star tries to be a little bit more efficient, which I'll show you how that works in a bit. But anyway, Dijkstra's, how this works is we're going to start off at A and try and get to E. So step one is we just put all of the nodes in there, and we're just going to put A is going to be equal to 0 there. And the other ones, they have the little infinity symbol there next to it as well, because we haven't visited those yet. So remove A from the queue, and then we look at the nodes which are next to A. Now, as you can see, the weight of the line going from A to B is 7, and the weight of the line going from A to D is 3. So D goes to the front. So D's going to be the first one because it's a shorter distance. And logically, that's the way that we're going to go for it. So if it's shorter, that's the one that you always visit first. So D goes there. So we put in for a 3 on that one. And then there's the idea of adding the distances together. Now, that can be a contentious point because some people find that a little bit confusing because they're like, well, but it equals 3. It's because A starts off as 0. With that one there, so that's why you would do 3 plus 0, which is going to equals 3, and 7 plus 0 equals 7. So that's why those values are there. We move B and D to the front of the priority queue. D is in the front because the distance is shorter. We've already talked about that. So that's step number 2 in there. So you just go to the nodes which are go next to your start node, and then you just go to the shorter one first. So we remove D from the queue because it's the next shortest space away. That's where we are in the search, and then we identify places that are connected to D. So identify the nodes that are connected, which is actually all of the other ones, which is B, C, and E. We change the values in those ones. So we're going to change B. We do 3 plus 2 because the distance going from A to D is 3, and then the distance going from D to B is 2. So that's going to give us 5, which is a shorter distance going from A, just directly from A to B. So that is why now B changes to 5, because that is a shorter distance. So that's going to take us less time to go there. C, we put in the values for that one. So going from we put 3 plus 4 because those ones they take us to C, which is going to be 7, and then E is going to be 3 plus 7 in that one there. Once we've done all of that, we're now going to remove B from the front of the queue because now we found the shortest distance because we tried 7 at the start, and when we went to D, that we found out that it was actually a slightly shorter distance there. So now we're at B, and we're now going to run some checks and see, are C and E going through this route, is it any shorter? So we look at these ones and we calculate the distances. So going to C from B is 3 plus 2 plus 3. That gives us 8. This is not shorter than 7, so we're not going to change this value. E is 3 plus 2 plus 6. So 3 plus 2 plus 6, because there's the line there. That gives us 11. This is not shorter, so we're not going to change. And then we take the C off, because obviously we want to see if actually going to C is going to be a slightly shorter route than going to E than any of the others. So again, we just run the check again. So it's going to be 3 plus 4 plus 1, or 7 plus 1, I've wrote down there, which is going to be 8. This is a shorter route then going 3 plus 7, which was 10. So we replaced that with E. So E is now going to become 8. And then we've done the search. So going through all of those different steps there is just about visiting the nodes that are connected to it, visiting the nodes, and working out the shortest possible routes. And the examiner, one of the things that I should say is, if you find a shorter route, there's nothing wrong with that. The examiner on the mark scheme actually wants to see that you've maybe crossed out that value. So you've crossed out the longer route, and then you've said this is the shorter route. So in the case of when we changed B, so the initial one was 7, wasn't it? When we were going from A to B, it was 7. So you'd cross that out, and then you've actually found out that going from A to D to B is a shorter route, so 3 plus 2. And it's just going through those steps, just visiting the nodes that are connected, and once you've done all of that, then you have found the shortest possible route to get to everywhere on there. But I mean, it was going from A to E, this one. Now, I'm going to go and trace through, I was having a look through some exam papers. I'm going to give you some tips on there for how to do the A-star algorithm, because generally the resources, I think, are terrible for the A-star algorithm, and it's really, really complicated. So one of the quick questions that you do sometimes see is just, what are the similarities and differences between A-star and Dijkstra's? So similarities, they both find the shortest path. That's their job. They're both shortest path finding algorithms. The difference is A-star uses this thing called heuristics, and sometimes they ask you just a simple 2-mark question: what is a heuristic? And essentially a heuristic is, and to get the 2 marks on this one, is I want you to say, is it's a best estimate or a best guess. That's 1 mark. And it's just trying to shorten the amount of searches it has to do to find the solution. Now, sometimes this is unavoidable, and it is going to have to check every single node, like the example that I'm actually going to show you. But the idea with the A-star, so this is the thing that you want to know from this and why it's slightly different from Dijkstra's, is the principle of this is to try and find a general rule of thumb that is going to get us a good guess to finding the solution, so that we don't have to do as many searches. So yeah, in some situations it is going to check every single possibility, but in other situations it actually won't. So those are some of the main differences on them. As I said, what I'm going to do is I'm going to show you how to a question from a paper, and I'll trace through and show you some of the things where you can grab some marks on it. I think one of the things that is going to be useful as well is just making a note of this calculation which the A-star algorithm uses to work out which node it should visit next. And what it does is it uses the actual distance of the graph, so the edge weight, and then also the heuristic, and it adds these two together. If the number is smaller, it's going to be less taxing for it to go there. Now, in some situations, it won't need to visit every single possible route, and that's the advantage that A-star has. It's not like Dijkstra's, which actually goes through every single possible outcome to try and work out what the shortest possible route is. We use this heuristic, this rule of thumb, to do this. So what I did is I had a little look through some of the exam papers, and we've got our start node, which is A, and we've got our end node, which is G. And what we need to do is we need to look at how we're going to get to G. Now in this one, you will be going through every single possible node because it's not a very big graph. But on a larger graph, and let's say that it was spread out over into all of these areas over here, one of the heuristics might be telling you to kind of head in this general direction. And so that you would actually possibly neglect going up this route. And that's what the advantage that A-star algorithm has. Now, a lot of us get hung up on the fact that with A-star algorithm, with anything, that we have to fully understand absolutely everything about it. And obviously that's the goal. But if you've only got a short time until the exams, and the only thing that you get is the similarities, the definitions of what a heuristic is, that's still going to put you in a great place to be able to get some more marks than if you hadn't have done. Now we're going to look at this example as well. I'm going to talk you through some of the stages, and again, you might be able to pick up a few different things. You might be able to pick up a 1 or 2 marks on this. If you get all of the marks on it, fantastic. That's going to be it. So let's have a little look at how we can go through all of this and how we can start off at the start. We're going to start off at A, and how we could fill in a table and what some of the different things that we're going to put into the table. So, first of all, the first node we visit is A. The distance is going to be 0 because that's where we're starting at. The heuristic is 90 because that's displayed underneath it. And then we just have to add the distance travelled and the heuristic together. So that's going to be 90. An area which I see a lot of students make a mistake on is that they add the heuristic for every single one of these. So it is, if you are stopping there, that is the heuristic you add to it. Okay? So that some people would, for example, they would, if I was visiting B, what they would do is they would do 21 plus 80, and then they would add 90 on as well. You don't do that. It's just 21 plus 80 because that's the one that we're visiting, which I'll show you in a second. So that's mistake number 1 that I see quite a lot. The previous node we're visiting is nothing because A is where we're starting. B, as I said, the edge weight from A, so we are visiting B because that is going to be the next one. It is a shorter route than going to C, so that's why we're going to go and visit B. So it's going to be 21. Then the heuristic is going to be 80. As we can see underneath there, adding those two together, that gives us 101, and the previous node is A. Next one, C. So we're going to go for C because that's the other one that's next to A. So we're going to go for 42. The heuristic is 65, as you can see underneath here. And then if I add those two together, that's going to give me 107. The previous node that I visit is A. Where it gets a little bit complicated now. Okay, so if you get those parts, so you can definitely grab yourself a mark for, so you get a mark per row, get a mark for locating the start node, putting in the distance travelled, which is always going to be 0 at the start node, the heuristic, just the thing underneath it, add them together, it's just going to be the heuristic, and the previous node is just blank or not available. Okay, that gets you a mark. If you can then work out what to do from that point, you can grab yourself a couple more marks there. So that's 3 marks there, people. This part is a little bit tricky. So let's just have a look at how we do this. So visiting D. Now there's a number of possible routes that we could use to get there. So first route I'm actually going to go for is, because B is shorter, I'm actually thinking that I'm going to be using that one. So if we have a look, it's going to be 21 plus 38. So we add those two together. And then what I'm going to do is I then have to add the, then my heuristic is going to be 50, so that gives me 109 there. Now, if I actually run the algorithm going the other way, so 42 plus 12, that actually gives me a smaller number, which is 54. I then add the 50 on, that gives me 104. This number is smaller. And in the mark scheme, they actually want to see that you've tried this one, and you've crossed it out. They don't just want to see that you've just gone straight to getting the correct answer in there, because logically this is how the algorithm would actually go, is it would be going this way because it thinks it could be shorter, and then it goes this one and it actually says, oh no, that one's actually the shorter route. So the previous node for this one is actually going to be C, not B. Calculating E. So for this one, it's going to make sense for us to go from B because we're adding in a load of extra routes there. So if we were to go through D, so for that one there, it's going to be 21 plus 40, which that gives us 61. The heuristic there is 50, as we can see underneath there. We add those two together, that gives us 111, and the previous node for that one is B. So F. So again, just going through that, it's going to make sense for us to go to D. So we already know what D is, which is going to be 42 plus 12 to get us to D, and then we just add the 23 on there, which gives us 77. 30 plus 77 gives us 107, and then the previous node for that one is going to be D. It wouldn't make sense to go around the other way. So again, we don't have to go through all of the different other possible routes like we do in Dijkstra's. And then the last one, so G. So in this one here, I did do a little check just to make sure, and as long as you don't write it in the box on that one, you won't be losing any marks there. But the quicker route is going to be to go through the route of going through to D, so we go 23, and then if I add on 33, that's going to give me 110. The heuristic there is 0, so the answer is going to be 110. The other way round is actually going to give us 116, so that isn't going to be the shortest possible route. So the shortest possible route is going to be A, C, D, F, and then finally G. Okay? As I said, there are some super complex concepts on all of that. And with this, if you can just remember the start node parts, if you can, and then that then causes you to be able to look at what nodes are attached to that, and then looking at the distances going to those, that's going to be great. If you can grab yourself 2 or 3 more marks that you wouldn't have naturally have got, fantastic. If you can then push on to get all of the marks on there, even better. But just focus on what you can. If you can just remember the keywords, that's great. If you can get a couple of marks on here, great. If you can get all of the marks, great. Best of luck, people. Hope that was useful. And I'll speak to you soon.